Our objectives in this lesson are the following. Define Pearson's sample correlation coefficient. Compute R by following steps using Spreadsheet and using Casio FX991EX. Interpret the strength of correlation between two variables based on the value of R. And apply and solve real-life problems involving Pearson's sample correlation coefficient. Let's have a quick activity. Describe my plots. In my previous lesson, we already discussed the form, the trend, and variation of scatter plots. Let us determine those for these two pictures. Number one, you can resemble a line here, so the form of this one is linear. Since we have here negative, so our trend is negative. Obviously, the rising line is from the right going to the left. For the variation as well as the trend, zero point 0.6 is somewhere in between 0.5 and 1. So this is a strong negative correlation. For the second picture, obviously this is curvilinear. This is neither positive nor negative, so we do not have a trend, no linear correlation. For the variation, since we do not have linear correlation, but obviously we have a strong curvilinear correlation. This time, we're going to talk more about Pearson's R. It is also known as Pearson's sample correlation coefficient, Pearson's correlation, Pearson product moment correlation. The proponent of this is Carl Pearson, a British statistician born March 27, 1857 at London and died April 27, 1936 at Cold Harbor. Let us discuss more about the Pearson R. It is denoted by R. It is a measure of the strength of a linear correlation between two sets of quantitative data. Here is the formula. I'm going to discuss this in detail later. The range of values for R is from -1 to +1. The larger the absolute value of R, the stronger the relationship. Pearson's R attempts to draw a line of best fit through the data of two variables and indicates how far away all these data points are to this line of best fit. Let us talk about line of best fit. To give you an idea, here are examples of line of best fit. This can easily be generated through a program. These three, I have created this in Excel. Line of best fit is a straight line that best illustrates the relationship between the points. It is a line that passes through as many points as possible. Take a look at picture number 1. It passes through almost all points, but not at all times. Take a look at number 2. It only passes through 2 points. And at picture number 3, it did not pass through any points on the plot. Another, the closer the points to the trend line, the stronger the correlation. Take a look at picture number 1. The points are very close to the trend line, so we have a strong correlation. Now, for picture 3, although the trend line did not pass through any points in this picture, but you will notice that the points here in picture number 3 are closer than the points here in picture number 2. That is why the correlation in picture number 3 is greater than the correlation in picture number 2. Of course, we have to consider the absolute value of these correlations. A line of best fit can be roughly determined using an eyeball method by drawing a straight line on a scatter plot so that the number of points above the line and below the line is about equal. Let us see. In picture number 3, we have 1, 2, 3, 4, 5 points above the trend line. And we have 1, 2, 3, 4, 5 points also below the trend line. In picture number 2, we have 1, 2, 3, 4, 4 points above the trend line. 1, 2, 3, 4, 4 points below the trend line. How about in picture number 1? We have 1, 2, 3. 3 points above the trend line, but only 1 below the trend line. That is why creating a trend line just by counting the points above and below is not that accurate. There is a more accurate way of finding it, and that is through the least square method. However, our lesson for today will focus only on the computation of correlation coefficient. Last lesson, I have already discussed the trend and variation and the corresponding value or range of R and how to describe it. Let's have an activity now. Interpreting R. Column 1 is for the bivariate data. Column 2 is the value of R, and we are going to write our interpretation in column 3. Number 1, elevation and temperature. As you climb the mountain, it gets colder. So what does it mean? An increase in height is a decrease in temperature. That is why we have a negative correlation here. So when we interpret this, 0.72 is somewhere in between 0.5 and 1. So that would be a strong negative correlation between the elevation and the temperature. Next one, minutes of walking and calories burned. The value of R is 0.35. This is somewhere in between 0 and 0.5, and that is weak. So there is a weak positive correlation between minutes of walking and calories burned. Next one, height and IQ level. The value of R is 0. So this means there is no correlation between the height and the IQ level. Last one is the length of service and salary. The value of R is 0.88. This is strong and positive. So we have a strong positive correlation between the length of service and salary. This time, let us talk about solving for R. So here is the formula and here are the steps. I'm going through this one by one and in detailed in our example. So here we have the grade level from 1 to 6 and the number of friends gained. Step 1, make a chart. Create columns for X and Y. So let us do that. Columns for X and Y. Add 3 more columns for xy, x squared, and y squared. Xy, x squared, and y squared. Assign values for x and y. So we are going to assign x and y for our variables. The idea is you will gain more friends if you are going to enroll every year. So I'll put grade level on the column of x, 1 to 6, and the number of friends gained on the y column, 6, 10, then 4. Step 2, multiply x and y. Write the product in column x, y. So we're just going to multiply this two. 1 times 6 is 6. 2 times 10 is 20. 3 times 7 is 21. 4 times 5, 20. 5 times 8, 40. 6 times 4 is 24. Step 3, square the values in x column. Write the result in column x squared. So we're going to square the values in x column and we're going to write the result in column x squared. So 1 is squared is 1, 2 is squared is 4, 3 is squared is 9, 4 is squared is 16, 5 is squared is 25, 6 is squared is 36. Step 4, square the values in y column. Write the result in column y squared. So this time we're going to square the values in y column and write the result in column y squared. 6 is squared is 36. 10 is squared is 100. 7 is squared is 49. 5 is squared is 25. 8 is squared is 64. And 4 is squared is 16. Step 5. Add all the answers in the columns. Write the answer at the bottom of each column. So it means we're going to add another row. And we're going to get the sum of each column. Let's start with column X. 1 plus 2 is 3. 3 plus 3 is 6. 6 plus 4 is 10. 10 plus 5 is 15. And 15 plus 6 is 21. Since we get the sum, we're going to use the symbol for summation. Summation of X is equal to 21. Next column, the Y. 6 plus 10 is 16. 16 plus 7 is 23. 23 plus 5 is 28. 28 plus 8 is 36. And 36 plus 4 is equal to 40. Summation of Y is equal to 40. Next column for XY. 6 plus 20 is 26. 26 plus 21 is 47. 47 plus 20 is 67. 67 plus 40 is 107. 107 plus 24 is 131. Next one for the X squared. 1 plus 4 is 5. 5 plus 9 is 14. 14 plus 16 is 30. 30 plus 25 is 55. And 55 plus 36 is 91. Summation of X squared equals 91. Last column for Y squared, 36 plus 100 is 136. 136 plus 49 is 185. 185 plus 25 is 210. 210 plus 64 is 274. And 274 plus 16 is 290. So the summation of Y squared is equal to 290. Step 6. Substitute the answers in the correlation coefficient formula. So once again, here is our formula. And here is the number of pairs. Since we have 6 grade levels, so that means we have 6 pairs. So our n here is equal to 6. So 6 for n. And then summation of xy, it's 131. It's here. And then minus. Summation of x is 21. Times the summation of y is 40. All over the square root. Our n again is 6. Summation of x squared is 91 minus the square of the summation of x, which is 21. Multiplied by, again, our n is 6. Summation of y squared is equal to 290 minus the square of the summation of y, which is 40. Computing this in our calculator, it will give us a value of negative 0.46. So this means we have a negative correlation, and since 0.46 is in between 0 and 0.5, so therefore there is a weak negative correlation between the grade level and the number of friends gained. Let us do extra challenge. As a financial analyst, you conducted research on the length of service of the employees versus the salary they are receiving. You randomly selected 6 employees in the company you're working with for this study. Solve for the value of R and interpret the result. So we have here the length of service in years 1, 5, 8, 10, 20, and 25, and their corresponding salary. Step 1. Make a chart. So we're going to create a chart for column X and Y. And then we are going to add 3 more columns for XY, X squared, and Y squared. Next, we are going to assign values for X and Y. Of course, you won't have salary if you're not going to work for a company. So the length of service comes first. This will be my variable X. 1, 5, 8, 10, 20, and 25. And the salary is my variable Y. I'll copy this in here. Step 2. Multiply X and Y. Write the product in column XY. 1 times 22,000 is 22,000. 5 times 3 is 15, then just add 4 zeros. 8 times 31 is 248, then add 3 zeros. 1 times 35 is 35, and then add 1, 2, 3, 4 zeros. 2 times 42 is 84, then add 1, 2, 3, 4, 4 zeros. 25 times 44 is 1,100, and then add 3 zeros. Step 3 is square the values in x and write the result in x squared. So 1 is squared is still 1, 5 is squared is 25, 8 is squared is 64, 10 squared is 100, 20 squared is 400, and 25 squared is 625. Step 4 is square the values in y column. Write the result in column y squared. So you may want to use your calculator here. 22,000 squared is 484 million. 30,000 squared is 900 million. 31,000 squared is 961 million. 35,000 squared is 1,225,000,000. 42,000 squared is 1,764,000,000. And 44,000 squared is 1,936,000,000. Step 5. Add all the answers in the columns. Write the answers at the bottom of each column. So we're going to add another row, and we're going to get the summation in each column. So 1 plus 5 is 6, 6 plus 8 is 14, 14 plus 10 is 24, 24 plus 20 is 44, and 44 plus 25 is 69. Summation of x is equal to 69. 22 plus 30 plus 31 plus 35 plus 42 plus 44 is 204,000. Let us add all of this, and this will give us 2,710,000. And let us add all of this, and this will give us 1,215. These are huge numbers. Adding them all will give us 7,270,000,000. Such a gargantuan number. By the way, let us count how many pairs do we have here. We have 1, 2, 3, 4, 5, 6. So our n later is equal to 6. Step 6. Substitute the answers in the correlation coefficient formula. This is the formula. Let us now substitute. Again, our n, I just counted it. That is equal to 6. Summation of xy, we have here 2,710,000 minus summation of x is 69. Summation of y is 204,000. All over is square root of n again is 6. Summation of x squared is 1,215. Minus the square of the summation of x, which is 69, times our n again is 6. Summation of y squared is 7,270,000,000 minus the square of the summation of y, which is 204,000. Computing this in our calculator, this will give us 0.97. 0.97 is very close to 1. So we have a strong positive correlation between the length of service and salary. Now, I am going to show you how to compute for the value of R using a spreadsheet. You can also do this in Excel. It's the same process anyway. So here is our data earlier. The first thing that I'm going to do is to write this in column form. So I'll copy 1 up to 25, right-click, copy, and then I'll place it anywhere, maybe here. Right-click again, paste special, and then choose transposed so that it will be in column form. I'll do the same thing for the salary. I'll copy this until 44,000, right-click, copy. I place it beside 1, right-click, paste special, transposed. Now I'm going to click on any other cell, maybe here, equal sign, type in Correl for correlation. You have it here, Pearson product moment correlation coefficient. Click that one. And then for the first set of data, choose this cell down to 25 and then comma. For the second set of data, choose this cell down to 44,000 and then click enter. There you have it. Our R is equal to 0.97, the same answer that we had earlier. This time, I am going to show you how to compute for the value of R using a calculator. This emulator is from Casio model FX570 or 991EX. Let us start. Press the menu button. Choose number 6, that is for statistics. Since we have two variables, length of service and salary, we're going to choose number 2. Then we key in our data. For the first column, we have 1. Press equal sign. Then we have 5. Next one is 8. Then we have 10. Then 20. And last one, 25. To move to the next column, just press this down. You'll go back to row 1, then press this one. So you'll be on the second column. Now let us key in 22,000. Next is 30,000. Next one is 31,000. Next one is 35,000. Then we have 42,000. And last one, 44,000. To check, you may press this button. See if your data is correct. If it is, click Option. Then choose number 4, Regression Calc. There you have it. Our R is 0.9701287178. When rounded off to the nearest thousands, it is 0.97. Exactly the same when we did the computation by steps and using a spreadsheet. For the summary, here are the things that we discussed in this lesson. Take time to understand this. Now, it is time to check your understanding. Pause this video for more time. Let us answer. Let me use my calculator in solving for the correlation of this one. Let's press menu. Choose number 6 for statistics. Choose number 2 since we have two variables. Now let us key in our data. 1 equal sign, 2, 3, 4, 5, 6, 7, 8, 9, and 10. To transfer to the next column, I'll just press this down here. I'll go back to row 1 and then I'll click this going to the right. I'll key in 88, 94, 86, 84, 92, 86, 94, 84, 92, and 88. You may want to check if your data is correct. If we are sure of our data, then let us press Option. Choose number 4 for regression calc. There we have it. Our R is equal to 0. So it means there is no correlation between the grade level and the average grade. Gets? I hope you understand our lesson for today and you enjoy the 3 methods that I have shown you. Feel free to write your comment below. Our next lesson is dependent and independent variables.